Hello everyone, I will be explaining how to do a multiple linear regression in SPSS today. To do so, first go to Analyze, then to Regression, and finally to Linear. I now have a dataset with four variables, number of friends, age, gender, and education. And we'll be using these three to predict the number of friends. So if we click on OK, we'll have our regression. That's as easy as it is. This is just shows which variables are in the data set. So in this case, there's only one model and you have the variable here. The model summary gives some additional values. The only one of interest is for now is the adjusted R squared, which is the number of friends varies from person to person, and the adjusted R squared is how much of that variance is explained by years of education, gender, and age. ANOVA shows you the whole model effect. So if you have the research question, can years of education, gender, and age predict the number of friends? Then here you'll find your answer. It's significant, so yes, you can. The regression is significant. So, and finally, we have the coefficients, which is the most interesting of the table of them all. And this says the effect, shows you the effect of the different coefficients. Here we have, I see that age and years of education are both significant while gender is not. The understandardized data here is the difference the 1 unit of this makes on the number of friends, which is actually really easy if you think about it, because what you're actually saying in common language is if you are 1 year older, so plus 1 year, you have minus 1.4 friends on average. And for years of education, you have plus 4.6 friends if you have studied a year longer. So sadly, this is a fake data set, so this doesn't really work that way, but it's a fun, but it does work that way for real data sets as well. Then we have the standardized coefficients, which are the sort of effect size. And as you can see here, this one is negative, which means that older is lower the number of friends, and years of education says more years of education is more friends. However, the effect size, despite the minus, can be interpreted as the same, while gender clearly has a smaller effect size and is also not significant. This is the basics. Now we'll go to see some other options. So we can go here back to linear regression, and I just clicked some wrong place. We now use the method enter. It's also possible to use the method stepwise. Now remember, age has the highest effect size, then years of education, then gender. If I click on OK, you'll see that they first enter age and then years of education. So gender was not significant and was not entered, and they just go from top to bottom with the effect size until it's not significant anymore. And that way we'll get the same results, but now we have two middles, one with only age and one with age of education, age and years of education. So that's stepwise. What's also possible is to enter them in a specific order. So now gender was removed, but I actually want it in. I remove gender and I go to next, and I'll add it as a second step. And my third step will be to remove the number of years of education. So we have one block with, wrong button. You have one block with age and years of education. The second block enters gender, and the third block removes years of education. And this will create 3 different models. Here you'll see what happens with each model, and here you have the 3 different models each time. And otherwise they will be interpreted the same way. Now, if we go back to the way it was, then we go over these options. First we have statistics, which provides you with all kinds of nice statistics, of which you might want to see the confidence intervals, and they also ask for collinearity diagnostics. Then we have plots which we will not be using, and options to style neither, and then we have save. Save actually adds another variable to the data set, and so you can use it to calculate other things. And they ask for the predicted values, standardized residuals, and Mahalanobis and Cook's distance. These 2 I will ask you to Google, just because they're not that difficult to handle. These ones I will show you too, how to use them. Okay, so if you click continue and OK, you can't see it because I'm currently in the output view, but they have now been added to the dataset. So here you can see the standardized predicted, standardized residuals, and the 2 distances. Do note that if you run it again without unchecking these, it will be saved again. So always, before running it again, uncheck unless you want to store them again. So now we have the same one again without. Okay, now this is as far as the multiple regression goes. Now I will go over how to handle the standardized residuals and the predicted values. Well, first the standardized residuals for the normality, conditional normality. They recommend using X4, and then we take the standardized residuals and put them in the independent list. And then under plots, we ask for the normality plots with tests. And we just display both. And then we here have the test of normality, which is significant. So this says it's not normally distributed, and you can see here this is the expected line, and it flows a bit all around it. So it's not quite normally distributed. You could probably use it anyway. Well, you'd have to see. It depends on the data. So that's how you handle the standardized residuals for normality. Then you're asked to do homoscedasticity. There are several ways to plot. I personally prefer chart builder. And then you click on OK. You can ignore that screen. And here you can choose your own type of graph. Now, for this we'll need a scatter plot, which is already, so you can just drag and drop it and it will appear here. And I'll just remove this and do them again. You can put the standardized predicted values on the y-axis and the standardized residuals on the x-axis. Then you can click on OK, and it will create the chart. For the homoscedasticity, the most important thing is does the size of the predicted value alter the standardized residuals? So what we actually are seeing here is that it's about approximately evenly distributed. So we have a few outliers here of sorts. You'll have to check the distances for if they're really outliers. However, there's no real, for example, if you have a cone shape, that's not good. That's no homoscedasticity. Here we have a very straight line with a bit of bloody, but there's no real pattern in it, and that shows that the assumption of homoscedasticity is met. So for the video, thank you for listening, and I hope it helps with the exercise.